So in today's lesson, we're going to talk about properties of special parallelograms. Yesterday we talked about parallelograms. Today we're going to add to that with some special parallelograms, okay? So a second type of special quadrilateral is what we call a rectangle. All of y'all have seen rectangles since you were little. So a rectangle is a quadrilateral with 4 right angles. So this is your first blank, 4 right angles. So again, notice that this is a quadrilateral, got 4 sides, but it's also got 4 right angles, okay? So here's a couple properties about rectangles. So if a quadrilateral is a rectangle, then it's a parallelogram, right? So obviously we know that opposite sides here are parallel, so this means that AB is parallel with DC, right? And BC is parallel with DA, okay? Then if a parallelogram is a rectangle, then its diagonals are congruent, okay? So remember, this means that AC is the same length as BD, okay? Now, what that also means is now all 4 of these are congruent because they still bisect, guys, because all the properties that we learned about a parallelogram apply to a rectangle, okay? So that means our opposite angles are congruent. Our consecutive angles are supplementary, which means they add up to B. So since a rectangle is a rectangle inherits all the properties of a parallelogram that we learned in lesson 4.1. So this says the rectangular gate has diagonal braces. So what does that mean? So it's asking us to find HJ. So notice that HJ is congruent with GK, right? And we have GK, so GK is 48 inches. So that's what HJ is, right? Okay, now it's asking us to find HK, okay? So this time it's asking us to find this diagonal right here. And we have that this part of this diagonal right here is 30.8, which means this is 30.8, right? So to find the whole thing, we would do 30.8 plus 30.8. Well, that would be 61.6 for the whole diagonal, right? So it would HK, we know HK is equal to what? GJ, right? So we just found GJ, didn't we? GJ was equal to 30.8 plus 30.8, so HK is going to be 61.6 as well. All right, so on this next one, we're going to talk about rhombuses. Now, a rhombus is another special quadrilateral, and a rhombus is a quadrilateral with 4 congruent sides. Now, this one has a few more properties that we're going to, now remember, this still inherits all the properties of a parallelogram because, once again, a rhombus is a parallelogram. So this means that AB, again, is parallel with DC, and that BC is parallel with AD, right? So every property that we had, our diagonals are bisect each other, our opposite angles are congruent, and our opposite sides are congruent is applicable here, okay? Now, there's one additional property, though, with respect to a rhombus, and that is, it says that the diagonals are perpendicular. So this is a really key term. Perpendicular means that they form a right angle. And honestly, if there's one right angle, then there's really 4 right angles, right? So because those 2 would form right angle, and these 2 would form a right angle. So every one of these angles, guys, in the center here is 90, 90, 90, and 90, okay? So that's what that means when the diagonals are perpendicular, okay? If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles too. So what does that mean? So let's just give these some angle measures. So let's just say that this one right here is 100 degrees, okay? We know that the opposite angle is 100 degrees, and if it's being bisected, then angle 1 would be 50 and angle 2 would be 50, right? Okay? So now, if we know that angle B is 100 and angle A and B are supplementary, right? So then we know that this angle down here is 80. And again, it's telling us that the diagonal bisects that. So that means that part would be 40 and that part would be 40. So now everything that I just showed you would be true with opposite angles as well, right? So this would also be 80 up here. So that would be 40 and 40. And over here, this would be 50 and 50. And notice we got a triangle here. You see that? And what does the triangle have to add up to be? 180 degrees, right? And we've got 40 and 50, that's 90, right? So we can also now see that this angle right here has to be 90, doesn't it? Okay? So everything's starting to add up. All right. TVWX is a rhombus. Find TV. Okay, so here we go again. So now when we start working through these, so we know the opposite sides are congruent, right? So we're going to say 3b minus 4 is equal to 13b minus 9. Now, all the sides in a rhombus are congruent, but we also have a pair of opposite sides here, right? So we're going to subtract 3b from both sides. So this is going to get rid of all the b's there, and so we're going to end up with 10b over here. And then we're going to add 9 to both sides. Was that a minus 9, y'all? Oh, and that's a plus 4. Sorry. That's what I was like. Something's wrong here. So I did this problem yesterday, so I remember. It's 13. Okay, then we're going to divide both sides by 10. So for b, we're going to get 1.3 is equal to b. But it's not asking us for b, right? It's asking us to find what? TV. Now, listen. To find TV, we must see that all 4 sides are congruent, right? So TV is equal to any one of these sides. So we can say TV is equal to xt. And then we know what xt is, right? Xt is equal to 3 times 1.3 plus 4. So I got that it was 7.9. Okay? Which makes sense, right? Because 3 times 1 is 3, and 3 times 3 is 9. That would be 3.9 plus 4 is 7.9. Okay? Now it's asking us to find m, the measure of angle VTZ. Well, I think they're asking us for VTZ, that angle right there, and it says that is 5a minus 5. But to find that, I got to find a, right? Now, remember that all the angles in the center here are perpendicular, right? So that's a right angle right there. So can't we set this equal to 90? Indeed. And then we can use that to solve for a, and then we can plug that a back up there in that 5a minus 5 equation. Okay, so we're going to subtract 20 from both sides. So it gives us 14a is equal to 70. And if we divide both sides by 14, a is equal to 5, okay? Now we can use that 5 and plug it back up in this equation right here, okay? So the measure of angle VTZ is going to be equal to 5 times 5, that's 25, right, minus 5. So that's going to be equal to 20 degrees, okay? All right, let's see if you guys can do these U-tries down here. Come back to me when you're done. So this time it says CDFG is a rhombus, find CD. So remember, again, all 4 sides are what? Congruent, right? So we can set any of the sides equal to each other. So we can say that GCG is equal to GF, and that's going to enable us to also find what? CD, right? Okay? Because all 4 sides, and we go ahead and say DF, all 4 sides are congruent, yes? Okay, so we can say 5a is equal to 3a plus 17. Subtract 3a from both sides. So we get 2a equals 17. And so 2 into 17 is what? Divide both sides by 2. So a is equal to 8.5, right? Okay, then we must plug that back in. Now, does it matter where we plug it in? Not really. Because remember, we said CG is equal to CD, right? See it right here? CG is equal to CD. So that means we can say 5 times 8.5. That's going to be equal to our CD, isn't it? So what is that equal to? 5 times 8.5 is 42.5. 42.5 is equal to CD. Okay? All right, now this next one says find the measure of GCH. Let's see where GCH is. Let's do this in a different color. GCH, that angle right there. If the measure of GCD, oh, now we got the whole big angle, don't we? GCD is the whole thing, is B plus 3. And the measure of CDF is this angle up here, CDF. Ooh, now we got, look, We've got this angle right here and this angle up here. What do we know about those two angles? They're supplementary, right? Because they are right next to each other. So angle C and angle D. So that means we can say B plus 3 plus 6B minus 40 are equal to 180, right? So B plus 6B is 7B. 3 minus 40 is 37, minus 37. That equals 180. We're going to add 37 to both sides. So that's 7B is equal to, what is that? 217. We're going to divide both sides by 7. So B is equal to 31. Okay, now we have B, but now we have to figure out. So let me erase this so we can go back here and talk over this again. So now notice what they want us to find here is GCH, which is half of angle GCD, right? GCD is right here. GCD is there. So what we want to do is find the angle GCD. So the measure of angle GCD is equal to 31 plus 3, and that's 34, right? So how are we going to find the measure of the angle that we're actually looking for, which is GCH? That's our red angle right here, GCH. I'm going to divide that 34 by 2. So the measure of angle GCH is equal to 34 divided by 2, which is 17 degrees. Okay? All right, so our next one is a square. So a square is a quadrilateral with 4 right angles and 4 congruent sides. So in the exercise, you will show that a square is a parallelogram, a rectangle, and a rhombus. So a square has the properties of all three. So remember the properties of parallelogram. Opposite sides are congruent, right? Opposite angles are congruent. Diagonals bisect each other. And consecutive angles are supplementary. What were the properties of a rectangle? They had 4 right angles, right? And we have 4 right angles here. And the diagonals were congruent, okay? A rhombus had 4 congruent sides, and the diagonals bisect the angles, okay? So those were the unique properties of a rhombus, okay? So rectangles, rhombuses, and squares are sometimes referred to as special parallelograms. So for example 3a, and then you guys are going to do B and C as the you tries. Okay, so we're going to do example 3a together. So it says, tell whether each quadrilateral is a parallelogram, rectangle, or rhombus, or square. Give all the names that apply. So let's talk about, so basically, obviously, because the diagonals bisect each other, we could say this is a parallelogram, right? And what else is it? It's also a rectangle, right? Okay. Well, okay, so now we're going to pause here, and you guys are going to go on, and you're going to do, and how did I know that all these other angles, y'all, were 90 degrees? Because consecutive angles are supplementary, right? So if that's 90, then the next one has to be 90, and this one has to be 90, and this one has to be 90. So if I see that one's 90, then all the rest have to be because of the properties of a parallelogram, okay? All right, so what about this next one? We can see that the diagonals bisect each other, right? So that's a parallelogram. Can we say it's anything else? I can't because I don't have any other information about it, okay? So now what about C? So C is also a parallelogram. And notice we have a right angle where the diagonals bisect each other. So this one also shows us that the diagonals are congruent. So this would also be a rectangle. Okay, and because we have that right angle, it would be a rhombus, which also means it's a what? So if it's a parallelogram, a rectangle, and a rhombus, it's really a what? Yep, you got it. It's a square. So the key here, y'all, is if a rectangle and it's a rhombus, it's a square. Okay? Okay, so then example 4a, you tries B and C. Okay, so we're going to do, it says find the value of x that makes each parallelogram the given type. So what kind of angle would we have down here in this bottom left? This is a rectangle, y'all. when we have a right angle. So we're going to say 90 is equal to 5x minus 3. We're going to add 3 to both sides. So that's 93 is equal to 5x. We're going to divide both sides by 5. So x is going to be equal to 18.6. Okay? All right, you guys go ahead and do B and C and come back to me when you're done. So this next one says it's a rhombus, so that means these sides have to be congruent, right? So that means we're going to set these equal to each other. 14 minus x is equal to 2x plus 5. I'm going to add x to both sides. So that's now gone, and I'm going to subtract 5 from both sides. So that's going to give me 9 is equal to 3x. So what would that be, y'all? X equals 3, right? Okay. The last one says it's a square. So if it's a square, it's a rhombus, right? And if it's a rhombus, we have right angles all in here, right? All of in here. All of those are right angles, right? So can't we set that equation equal to 90? Yep, 90 is equal to 13x plus 5.5. So we're going to subtract 5.5 from both sides. That's going to give us 84.5 is equal to 13x, and then we're going to divide both sides by 13. Right? So x is equal to 6.5. All right, we're done.